Alright guys, let's see how we can solve question 8 from the second chapter of the Meriam textbook Engineering Mechanics. And in this one we have a small probe P that is gently forced against a circular surface with a vertical force F. As we can see in the figure, so we have this force that is applying onto this small probe P. And we need to determine the N and T components of the force as functions of the horizontal position S. So we have S, which would be the horizontal position of the probe, and we have to find the N and T components of this force. And the way we're going to solve this question is that, so if we look at force F, we know that the radius of this circular surface is R. So if we connect the point O to where the probe is applying the force, we're going to have the radius, so this will be our R. And based on the question, if we continue this line, we have this distance here, what we have in here, which is our S. And if we connect these two, we're going to end up with the right triangle, and we can call the other side in here maybe A. And our force F is applying in here, which we can show it like this, the force F. And we can dissolve this force into two components of N and T. So if we consider this line our N and T, if we want to resolve the force F into N and T component, this will be our Fn, and this is going to be our Ft, which the resultant of these two forces is going to give us the F. So let's call this angle over here alpha. So if that angle is alpha, this angle right here would be alpha 2, because we have the vertical force F parallel to what we have. So these two are parallel, and we have this is crossing, so these two are the same. So let's figure out the Fn and Ft. If we look at the Fn, we'll see that our Fn is first of all acting along negative n axis, so we're going to have negative F times the adjacent of the alpha would be the Fn, so we need the cosine of alpha in order to find that one. And for our Ft, first of all, as we can see, it's acting along positive t-axis, so we have F times this time. This would be the same, so it's the opposite of the angle alpha, so we're gonna have sine of alpha. But the question is asking us to find it based on the position S, or as a function of the horizontal position S, which is one side of this right triangle that we have. So if we do the Pythagorean theorem for that right triangle, we know that the r squared is equal to a squared plus s squared. So if you want to find a squared, we simply have r squared minus s squared. And if we do the square root on each side, our a would be plus or minus the square root of r squared minus s squared. We are dealing with dimensions, which means the negative sign doesn't make any sense. So our a would be r squared minus s squared. So we found our a as a function of s. And also, if you look at this right triangle that I drew in here, this one, which I'm highlighting in yellow, we should be able to find the value of sine and cosine of alpha. So if we want to find cosine of alpha based on that the yellow triangle, we're going to have the adjacent, or a, over the hypotenuse r, and for sine of alpha, we're going to have the opposite, s over r. And we already found a based on as a function of s. So here our Fn would be minus f times a over r. Our a is square root of r squared minus s squared over r. So we found our Fn as a function of s. And for Ft, we're going to have f times sine of alpha, which is basically s over r. So this is going to be the final answer for this question. We found the two components for our force F. So hope everything was clear. You guys take care. I'll see you in the next one.